here. In last class, we were discussing about the ring chain isomerism. So what is called the ring chain isomerism? So ring chain isomerism is nothing but the compounds are having same molecular formula. Okay. So but differ. That means open chain compounds are converted into the cyclic rings is called as a ring chain isomerism. Okay. Sir, how we can which compounds are which open chain compounds are they converted into the cyclic rings here? Either alkenes, alkynes. Okay, so alkadienes also they converted into the cyclic rings. For that one already I had given one example, simple example. Okay, to exhibit the ring chain isomerism, minimum how many carbon atoms it has to be there in a given compound? So minimum how many carbon atoms it has to be there? Minimum 3 carbon atoms it has to be there. So minimum how many carbon atoms here? So minimum 3 carbon atom it has to be there to exhibit as a open chain compounds into ring chain isomerism. Okay, and I'll give one more example. So what is another example means here? For example, butene is there. So butene, butadiene. Okay, so butadiene, 1, 3 butadiene. How we can write the structure of the 1, 3 butadiene means here CH2 double bond CH bond CH double bond CH2. It is also it undergoes to the ring chain isomerism. If it undergoes to the ring chain isomerism means it forms cyclobutene. Okay, so what is the product it forms here? Cyclobutene is going to be formed. Cyclobutene is going to be formed. Now you got the clarity? Okay. So you may get the doubt. Sir, how it is formed as a cyclobutene? How it is as 1, 3 butene is converted into the cyclobutene means here. So based on displacement reactions. All of you know resonance. What is meant by the resonance? I think so last time also we had seen some resonance structure. Is it right? What is meant by the resonance? Anjan, what is meant by the resonance? So resonance is nothing but delocalization of the pi electrons only, na? Okay. So first of all, I'm giving the numbering 1, 2, 3, 4, 7. Okay. So when these pi electrons are shifted on these carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. You got the clarity? And again, when these pi electrons are shifted on these carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. So oppositely charged ions are they attracted together. Okay, that means in between second and third carbon atoms. So one carbon atom is having the positive charge, another carbon atom is having the negative charge. If it is having positive charge and negative charge means in between the second and third carbon atom one double bond is formed. That is what I wrote as this one. This is the second carbon atom and this is the carbon atom. And if you see first carbon atom CH2 group it is there and fourth carbon atom CH2 group. So fourth carbon atom is having the positive charge and the first carbon atom is having the negative charge. Again, one more new bond is formed between the first and fourth carbon atom. Now, whenever it forms a new bond between the first and fourth carbon atom, it becomes as a cyclobutene. Now you got the clarity, everyone. Sir, one more example. And then do you understand this one?
Yes, sir.
Okay, so how we are converting into the butene into so 1, 3 butadiene into cyclobutene. And one more also I'll give. What is another example means here? Butane. So what is another example means here? Butane. So CH3 bond, CH2 bond, C triple bond, CH. Okay, C triple bond, CH. Actually, this we can call as a 1-butane. Okay, so what we can call as means here 1-butane. So 1-butane also it is converted into cyclobutene. I'm keeping the first and second carbon atoms like that only. and the new bond is formed in between first and fourth carbon atom. Whenever the new bond is formed in between the first and fourth carbon atom, it is converted into cyclobutene. Okay, Samhita, you got the clarity? Okay, now based on this one, I'll ask one question, sir. So what is the question
I
means
did not
here?
understand this last one, like cyclobutene.
So how you are
Yes.
getting answer? Okay, so second one you understand, sir? Sir, let us see when these pi electrons are shifted on these carbon atom, this carbon gets a negative charge, sir. Is that clear? And this carbon is having positive. This carbon is having here positive. But last carbon is containing how many hydrogens? Anja, the last carbon is having how many hydrogens?
3.
3. Okay. The last carbon is satisfied with the tetravalency or not, sir?
Yes, sir.
Okay. Sir, in this one H minus ion. One H minus ion is shifted from the fourth carbon atom to second carbon atom. If the fourth carbon to second carbon atom means, then the last carbon atom CH2, it becomes as a plus, and this one is converted into the CH2, and this one is converted into CH, double bond CH minus is there. Okay, shifting hydrogen shifts it happen. So that is only we can call as a rearrangement reactions. We have types of reactions, Anja. So we have types of reaction. So there we are going to study about this one here. So we have different types of the reactions. Addition reactions are there, substitution reactions are there, rearrangement reactions are there. Okay. So this is the one of the example of the rearrangement reaction. Now you got the clarity?
Yes, sir.
Okay. So now the last carbon atom is having the positive charge and the first carbon atom is having the negative charge. Okay. Then the first carbon atom and the last carbon atom, okay, combined together means they form as a new sigma bond. So then only it is converted into butene, which butene means one butene. Okay, so one butane is converted into one butene. Okay, now you got the clarity? Okay, so I'll ask one question, sir, based on this one. So how they're asking the questions in the NEET, so JEE level examination means they'll use some molecular formula. They're asking to calculate the total number of total number of, sorry, ring chain isomers. Okay, if they had given, sir, for example, if they had given, sir, if C5H10 I had given, C5H10. The given compound exists the number of ring chain isomers. Okay, so options are, what are the options means here? First option is 3, second option is 4, the third option is 5. Sir, next option is 6, sir. Right, sir. Options also I had given, sir. The total number of ring chain isomers are exhibited by given compound. Total number of ring chain isomers are exhibited by given compounds. What is the answer, sir? Option A 3, option B 4, option 3 5, sorry, option C 5, option D is 6. What is the correct answer, sir?
Sir, once can you repeat the question, sir?
The total number of ring chain isomers are exhibited by given compound. The molecular formula of the compound is C5H10. The total number of ring chain isomers are exhibited by given compound. That is my question. The molecular formula of the compound is C5H10. Any guess at least? All ring chain it has to be there. Can I explain? Samhita? Samhita?
Yes, sir.
So you got any idea about this question?
Sir, I think it's 5 or 4.
So you think it is the 5 or 4? So of course you are also a little bit in diagonal. So you're expecting 4 or 5 is the answer. Then what about the Anja?
Yeah.
Anja, which one answer you are expecting? Samhita is guessing as answer is either 4 or 5. What about your answer?
5, I think, sir.
You think so? 5? Okay, let us see, sir. So first of all, C5H10. C5H10 general formula of the molecular formula of the cyclopentane. Okay, so cycloalkenes, alkenes general formula is same only. So C5H10 means you will get as a cyclopentane. So cyclopentane also we can write as a methyl cyclobutane. Cyclopentane also we can write as here methyl cyclobutane. So you got as a 2 ring chain isomers. And sir, this also if you modify slightly, this also we can write as a ethyl cyclopropane. Okay, you got as a one more structure. What is the name of the another structure? Means that we can call as a ethyl cyclopropane. So we can get as a one more structure also with the same molecular formula. What is the molecular formula? Means 1,1 dimethyl cyclopropane also. What is the another structure you are getting as here? 1,1 dimethyl cyclopropane. Okay, and we can get another structure also, sir. What is another structure you will get as means here? 1,2 dimethyl cyclopropane. Other than this, is any other structures are possible? Any guess? Then the total number of ring chain isomers are exhibited by the C5H10 is. What is the correct answer now? What's the correct answer? Already structures are there in front of
5, sir.
5 is the exact answer. Samita, you got the clarity?
What, sir?
So you got the correct answer?
Yes, sir.
Okay, the total number of ring chain isomers are exhibited by the C5H10 is equal to, so total 5, sir. So like this kind of question they're asking the examination part. Okay. Right, ma'am. So then, so can I go for the next concept?
Sir, I have a doubt.
Yeah, ma'am.
So the first carbon bonds with the fourth carbon which has the pi bond, right?
Yes, ma'am.
Okay. How about if the pi bond is present on the third carbon?
Ma'am, if it is multiple bond, let us see. Sir, you're asking, sir, CH2, CH3 bond, CH2 bond, CH2, CH, double bond, CH2. Okay, so this is the question you are asking. Okay, now let's see. When these 5 electrons are shifted on this carbon atom, this carbon get as a negative charge, and this neighboring carbon will get as a positive charge. So based on the shifting, 1,2 shift means you will get as a ethyl cyclopropane. Okay, if the hydrogen is shifted from this carbon atom means the product you will get as a ethyl cyclopropane. So otherwise, if the hydrogen is shifting from this carbon atom, okay, then you will get as a methyl cyclobutane. Okay, otherwise, if the hydrogen is shifts from the last carbon to second carbon atom, and the last carbon and first carbon are combining together to form as a cyclopentane. Got it?
My doubt is, sir, if the double bond is present on the second or third carbon, then how do we draw the structure?
And that's so right. You are asking, sir, if the double bond is present. So CH3 bond, CH2 bond, CH double bond, CH bond, CH. So this is your question now. Let us see.
Yes, sir.
Okay. So when pi electrons are shifted on this carbon and this carbon get as a negative charge, this carbon get as a positive charge. So according to that one, if the hydrogen shifts from last carbon to this carbon atom, that time the carbon get as a positive charge. Okay, if the hydrogen shifts means, so that we can write as a here CH3, here already CH negative is there. Okay, then again systematic manner I'm writing CH2 bond. So this is also CH2, and here CH2 plus it becomes. So how it becomes as a CH2 plus means, because of last carbon is donates the hydrogen to the third carbon atom. Third carbon atom is converted into CH2. So third carbon is converted into the CH2, and last carbon becomes as a CH2. Okay, and two opposite charge are present side by side. If two opposite charge are present side by side means the new bond is formed in between the two carbon atoms. Na? It forms or not, Samhita?
Yes, sir.
So then it becomes as a, what is the structure it is? As per you. What is the name of the structure?
One methyl cyclobutane.
Very good, ma. So 1-methyl cyclobutane is the correct answer. Now you got the clarity how it is forming as a ring chain isomers and at all. So possible formation of the ring chain isomers is depends upon shifting of the H minus ion. Is that clear? Okay.
Yes, sir. Yes, sir.
Then, so I'll go for the next question, sir. So this is about the ring chain isomerism, sir. Ring chain isomerism also is one of the important. Okay. So next we'll go for the stereo isomerism, sir. Okay. Next we'll go for the stereo isomerism. So what is meant with the stereomerism until we had seen structural isomerism? What are the structural isomers we had seen? But tomorrow do you have test? Actually, I didn't get any message about the test. Tomorrow is working day or holiday? Anita,
Sir,
I think it's a
usually they
holiday,
give
sir,
it us.
tomorrow is holiday.
because of the Diwali, I think. So I don't know.
Diwali. Okay. So that is only I'm also having doubt. So because I didn't get any message about your Sunday's examination. Okay. So just I'm asking, I'm confirming with you. If it is there means I have to upload the question paper. I think so tomorrow is Diwali. Everyone you are busy with the celebrating of the Diwali. Okay. I don't know when you are going to be sure. So tomorrow also, and what about day after tomorrow? Day after tomorrow is holiday for you.
Yes, sir, it's holiday for.
Okay. Then Samita, what about yours?
Yes,
You
sir.
also it's a holiday. Okay, so then I'll do one thing. So better write the test on Monday. Okay, so tomorrow I'll print the question paper and post in your, I'll update in the app. Okay,
Okay,
right
sir.
now. So next, so we'll see about here stereo isomerism. So what is the stereo isomerism? Until here we had seen the structural isomerism. Stereo isomerism only. Sir, hello alkenes, halogens chapter is finished in your school now. Hello alkenes, halogens. This chapter is finished or not in your schools?
Finished, sir.
Okay, Anjan. What about Samhita? What about you? Sir, there you are reading as a stereo isomerism. I think so. You must read about the optical isomerism. Optical isomerism is comes under the stereo isomerism only. So what is meant by the stereo isomerism is? So stereo isomerism is nothing but the spatial arrangement of atoms or group of atoms around the carbon in a three-dimensional space is called as a stereo isomerism. Okay, so what is meant by the stereo isomerism, sir? It is the spatial arrangement of atoms or group of atoms around the carbon in a three-dimensional space is called as a stereoisomerism. Again, stereoisomerism is classified into two types. Stereoisomerism is classified into how many types? It is classified into two types. What are the two types of the stereoisomerism? It is there means here. So one is a conformational isomerism. One is conformational isomerism. Conformational isomerism. And another one is configurational isomerism. Another one is configurational isomerism. Okay. So where we are going to study about the conformational isomerism means in hydrocarbons, alkenes chapter is that. So which chapter, ma? Alkenes. Okay. So there we are going to study about the conformational isomerism. Okay. So what is the conformational isomerism? Okay. So what is the conformational isomerism means? Conformational isomerism are exhibited by the alkenes. So why the alkenes are they exhibit as a conformational isomerism means in alkenes carbon-carbon single bond it is there. Carbon-carbon single bond it is there, sir, here. Okay. So while having the carbon-carbon single bond, okay, so they'll rotate little bit freely. Okay, not that much here. They can rotate little bit freely while comparing with the alkenes and alkynes. While comparing with the alkenes and alkynes, alkanes are in between the carbon-carbon single bond it is there. So that carbon atoms are rotates freely. Whenever they rotates the freely means you will get as a new structures. All that new structures are we can call as a conformers. And the phenomenon is called as a conformational isomerism. So whenever we are going to discuss about the conformational isomerism, that time clearly with diagrammatic representation, exceptional cases, everything I'm going to be explaining. Okay, so now we have a less time. I can't explain the conformational isomerism. So next easiest one, first of all, we can check it out. Then we'll go for the conformational isomerism. Okay, next. So configurational isomerism. So configurational, what is meant by the configurational isomerism means here? So isomerism are exhibited by restricted molecules. Okay, so conformational isomerisms are exhibited by restricted molecules or restricted compound. So what is meant the restricted means here? The compounds which contains the carbon-carbon double bond and the compounds which contains the carbon-carbon triple bond, sir. But in this one, carbon-carbon triple bond means it is not possible. So which one we can take means the compounds which contain the carbon-carbon double bond we are taking. Okay, and carbon-nitrogen double bond also we are considering. And nitrogen-nitrogen double bond also we are considering it as a configurational isomers. Okay, so we are telling as a restricted. So what is mean the restricted means they are restricted about the rotation. They are restricted about the rotation. Sir, how you are telling that the restricted by the rotation means here, sir? Of course, I think so. You won't get the video is clarity, but I will try to explain you. I will show something to you. If you are able to see me, just to tell me that. Okay. So first of all, are you able to see me? Are you able to see? Both of you, Anjan?
Yes, sir.
Okay. Anjan, now you got some image. Just if you see means, sir, let's consider this is a one carbon atom. So I'm showing as a one hand. That we am considering it as a one carbon atom. And another hand I'm considering it as a one more carbon atom. Okay. Now, so two carbon atoms are attached with double bond. So how many pens are there in between the two atoms here? Two pens are there. How many pens are there, Anjan?
2 pens.
Right, Anjan. Now, some people let us see if I'm rotating, sir. If I'm rotating the carbons. If I'm rotating the carbons means here, sir, pens are becomes like this here. Exactly. Are you able to see means? Sir, if they are able to rotate, is both carbons are they are able to rotate, sir?
You can't see your screen, sir. Yes.
Screen is not clear.
No, sir, the background is coming in between.
Right now. So if you want to rotate freely means here, the bond is pi bond is going to be break here. So that's why rotation is not possible. Otherwise, what I'm telling that if it won't be single bond. So single bond only it is there. If it is having single bond means here, let's consider one carbon I'm keeping as a constant. Okay, I'm keeping as a carbon is a constant. Another one I'm rotating. If I rotate it some 60 degrees means you got as the same image or different image? Some different. If I'm rotating somewhat 60 degrees, you got same image or different image?
Different, sir, for all cases.
Yeah, if I'm rotated one more 60 degrees, sir, you got as some other different, na? So by rotating 60 degrees angle, so what are the new structures we will get as that we can call as a conformers. So conformational isomerism is the restricted compounds which are unable to rotate, that compounds are exhibited by configurational isomerism. Okay, so what is the configurational isomerism means? Configurational isomerism also is nothing but arrangement of the atoms. Okay, configurational isomerism also is nothing but here arrangement of atoms or group of atoms in a restricted molecules is called as a configurational isomerism. Okay, arrangement of atoms or group of atoms around the carbon in a restricted molecule is called as a configurational isomerism. So again, configurational isomerism is classified into two types. Configurational isomerism is classified into two types. So one is called as a geometrical isomerism. Another one is optical isomerism. I think so. Optical isomerism you may study in 12th standard in haloalkanes and haloarenes chapter. So where you have studied means here. So you must study it in haloalkanes and haloarenes chapter. Okay. Right. So how many members you know about the geometrical isomerism? Any one of you? Samvita or Anjan? So what is meant by the geometrical isomerism? Under the geometrical isomerism, which isomers we are studying here?
Sir, is it like cis and trans?
Very good, Anjan. It is cis and trans. Next, cis and trans are others. So what are the others?
Yeah, sir.
Samita, what about your idea? Excluding cis and trans others, what you are having idea?
That only, sir, system trans only.
Cis and trans only, yeah. You don't know others also. Actually, we have some other different also, ma. Okay, under the geometrical isomerism, we are going to study about here cis and trans isomerism. This is the one. Another one is E and Z isomers. EZ isomerism also we can call. Okay, that is also we are going to study under the geometrical isomerism. And syn and anti-isomerism also. Syn and anti-isomerism also we are going to study under the geometrical isomerism. Okay, so in this one shall we see first of all cis and trans. Sir, all this one, let's see either cis and trans, EZ isomerism, syn and trans isomers are exhibited by alkenes. That means the compound which contain the C double bond C, that compounds are the exhibit as a cis and trans isomerism. At the same time, the compounds in a compound with the carbon is attached with 4 different atoms or group of atoms. That means A, B, C, D type, that it is exhibited by the EZ isomerism. And syn and anti isomerism are exhibited by azo compounds, azo and oximes. Azo and oximes is exhibited by the syn and anti isomerism. Okay, shall we see first of all cis and trans? Shall we see Anjan, cis and trans? What is mean the cis and what is mean the trans, Anjan? You're telling that cis and trans we know.
Like cis means they both lie on the same side, sir.
Okay, so identical groups are present at the same side, mean that we can call as a cis. If the identical atoms are present at opposite direction, mean that we can call as a trans. Is that clear?
Yes, sir.
Okay. So can I give some examples? Can you expect which one is the cis and which one is the trans and which one is exhibit as a geometrical isomerism? Okay. Now I'll ask some questions. C double bond C. Okay, here the compound is A and B. So this one is A and this one is B. And C double bond C. So this one is A. So this one is A and B. Now my question is, I had given two structures, sir. I had given two structures. So in this one, which one is exhibited as a cis and trans isomerism and which one is not exhibited by the cis and trans isomerism? Two structures are there.
So
Two
first
structures.
one is this.
So my question is, I'm not asking any cis and trans. Just okay, cis and trans both also. Cis first one is cis. Then what about the second one, sir? And then what about the second one?
Sir, it's trans.
Sir, it won't be trans. We are telling the trans.
No, so sorry, it's not trans. Like, okay. Okay,
Sir,
the three. Okay, sure, I was confused.
sir, it does not exhibit the geometrical isomerism.
It's not, yes, sir,
Whatever
it's
you
not.
said. So because of first one, it is the cis only. It is exactly correct, Anjan. So because of two identical atoms, that means A are present at same side of the double bond. If identical atoms are present at same side of the double bond, with that we can call as a cis isomer. If the identical atoms are exactly present at opposite direction, for example, same structure I'm writing like this: B here A it is there, and here B here A it is there. If the identical atoms are present at opposite direction, with that we can call as a trans. Okay, sir, how we can explain the cis and trans means based on the identical atoms. If the identical atoms are present at same side of the double bond, with that we can call as a cis. If the identical atoms are present at opposite direction, with that we can call as a trans. But in the second structure, on which basis we can explain whether the given compound is cis and trans? Okay, so because of in this one the carbon is attaches with the identical atoms. If it is attaches with the identical atom means it does not exhibit as a geometrical isomers. Now you got the clarity. Okay, now you got the clarity, sir.
So could you
Can I
repeat?
give? Yeah, ma. Ma, let us see in alkene C double bond C. Each carbon is attaches with two different atoms or group of atoms, then only it exhibit as a geometrical isomerism. Okay, in an alkene, each carbon atom, for example, we can take as this carbon atom. If this carbon atom, it has to be attached with two different atoms or group of atoms, and this carbon also it is attaches with the two different atoms or group of atoms, then only it exhibit as a geometrical isomerism. Okay, if this one attaches with the identical one, for example, if it is like this, C double bond C it is there. Sir, here A, here B, here B also it is there. Either the given molecule is exhibit as a geometrical isomerism, sir. Last one.
No,
Is the
sir.
last structure? No, sir. Because of we can't say either it is cis or trans. Okay, so we can say trans only. So because of both are cannot be exhibited as a trans only, na? Okay, so that's why it does not exhibit as a geometrical isomerism. Okay, so which one is exhibit as a geometrical isomerism means M sir C AB type. Okay, so can I give some examples, sir? Few examples. Okay, so now I had given some different formation. So exam point of view, we can see it. Sir, C double bond C. Sir, ethene it is there. H, here also H, here also H. This we can call as a ethene. Is ethene is exhibit as a geometrical isomerism now?
Yes, sir.
Ethene. How it is? All are identical atoms only, the Anjan. Anjan, once you check it out, each carbon is attached to
Sir,
the
then
atom.
it will become like both now, sir. Then it will become like cis and trans, right?
No. How we can say which one is the cis? So can you explain that given the structure, it either it is the cis or trans?
Like it's existing both now, sir. Like if you check like crosswise, both are like okay, no, they're same. Okay.
Identical atom. Here also hydrogen, here also hydrogen, here also hydrogen, here also hydrogen only. All are identical atoms only, Anjan. If all are identical atoms means it is not possible. Okay. And one more example I'll tell here. Here also H, here also H, here also CH3, here also CH3. Either the given molecule also it exhibits as a geometrical isomerism, it is not exhibit as a geometrical isomerism. Okay. So I'll give one more structure, sir. C double bond C, here also CH3, here also CH3, here also H it is there, here also H. Now you can say, sir. Now you can say, sir, if identical atoms are present at same side of the double bond or not.
Yes, sir.
Okay, if the identical atoms are present at same side of the double bond, with that we can call as a. So two structures I had given. So which one is the cis and which one is the trans?
First one is cis, second one is trans.
Very good, Anjan. Anjan, on which basis you are telling that first one is the cis and second one is the trans?
Because they both are like same side, like identical towards each
Right, sir. Sir, let's see if you take methyl groups. Methyl. So this is the plane, sir. Okay. So two identical atoms are present at same side of the double bond. Here also hydrogen. Two hydrogen atoms are present at same side of the double bond. But in this one, Anjan, two methyl groups are present in exactly opposite direction. Okay. Here two hydrogen atoms are there exactly they present in the opposite direction. When they present in opposite direction, means that we can call as a trans. This we can call as a cis. Now you understood? All of you? Samhita, you understood?
Yes. Yes.
Okay. So remaining will continue in the next class. I think so. You have it.